Hey everyone, and welcome. Today we're going to dive deep and demystify one of the most important, and let's be honest, confusing parts of your computer. Its memory. We're going to break down what really makes your favorite gadgets feel fast or slow, all the way from the teeny tiny memory inside the processor to the vastness of the cloud. Let's get into it.
Okay, so first up, we've got to get our heads around the fundamental challenge that computer engineers were up against. You see, they were building these mind-blowingly fast processors, but those processors are always thirsty for data to work on. And actually getting that data to them, well, that became a huge bottleneck.
You know that feeling, right? You just dropped a ton of money on the latest, most powerful piece of tech, but you click on an app, and there's still that little frustrating pause. You're left wondering, what's really going on here?
Well, here's the secret. The problem usually isn't the processor at all. Modern CPUs are absolute speed demons. The real slowdown, the thing that makes you tap your fingers on the deck, is the time the processor spends just waiting for information to make the journey from the computer's main memory, what we all know as RAM. That conversation between the two is a major choke point.
And just how bad is this wait we're talking about? Well, it's staggering. If a modern processor had to get all of its data directly from the main RAM, its performance would plummet by over 95%. Let that sink in. All that incredible power, pretty much useless, just sitting there twiddling its thumbs. This is the problem they had to solve.
So, how in the world did engineers get around this massive performance killer? Well, they didn't find one magic bullet. Instead, they came up with something way more clever and elegant, a hierarchy of memory.
See, they realized that a one-size-fits-all approach just wasn't going to cut it. So they organized memory into layers like a pyramid. And this pyramid is really the key to understanding how your computer works under the hood. At the very top, you have the fastest, smallest, and most expensive memory. And as you go down the pyramid, a memory gets way bigger and way cheaper, but also a whole lot slower.
This really spells out the fundamental trade-off. It's like a law of nature in computing. You can't have it all. You can't have memory that's lightning fast, absolutely massive, and super cheap. It just doesn't exist. The whole system is this beautiful, intricate balancing act between speed, size, and of course, cost.
Right at the tippy top of our pyramid, living right on the same piece of silicon as the processor's brain, is something called the memory cache. You can think of it as the processor's own personal, super-fast notepad. Its one and only job is to hold the little bits of data the processor is most likely going to ask for next, so it doesn't have to make that long trip to RAM.
Okay, here's my favorite way to think about this. Picture your processor as your kitchen. It's where all the work gets done. Your main memory, the RAM, that's like the giant supermarket down the street. It has everything you could possibly need, but, it takes time to drive there, find a parking spot, and get what you need. And the cache? The cache is your refrigerator. It's small, right? But it's got the milk, eggs, and butter you're constantly reaching for, just an arm's length away.
Now, the reason this whole refrigerator idea works so brilliantly is because of a predictable pattern in how programs behave. It's called temporal locality, which is just a fancy way of saying that if a computer uses a piece of data, it's very likely to need that exact same piece of data again really soon. The cache totally exploits this pattern, which makes our refrigerator incredibly effective.
All right, so let's take one step down that pyramid from the super fast cache to the component most of us have actually heard of, and maybe even tried to upgrade ourselves. Good old RAM.
So, RAM is basically your computer's active, conscious workspace. When you fire up a program or open a document or click on a new browser tab, all of that information gets loaded into RAM for quick access. But here's the catch, and it's a big one. RAM is volatile. That's a key word. It means it's temporary. As soon as you cut the power, poof, the entire workspace is wiped completely clean.
Now, this is where people get confused because there's another type of memory called ROM, but honestly, they couldn't be more different. Think of it this way. RAM is the temporary rewritable disk you're actively working on. ROM, or read-only memory, is more like the permanent printed instruction manual that came with the device. It holds the super essential startup code, like the BIOS, that tells the computer how to even wake up in the first place. It's set at the factory, and you can't change it.
Okay, let's bring this into the real world. When you're shopping for a new computer or a motherboard, you'll see these terms thrown around, like DDR4 and DDR5. This is just talking about the generation of RAM, and knowing the difference can actually help you make a much smarter buying decision.
I mean, just look at how fast this stuff evolves. Each new generation of what's called double data rate RAM gets faster and uses less power.
From DDR3 way back in 2007 all the way to DDR5 today, the trend is crystal clear. More speed, less power, and better design for the kinds of multi-core processors we all have now.
So, the big question is, do you really need to shell out for the latest and greatest DDR5? Well, it depends. DDR5 offers a massive amount of potential bandwidth, which is great if you want to future-proof your system for years to come. But honestly, high-quality DDR4 is still an incredible value and provides more than enough horsepower for what most of us do every day.
And this is really the bottom line here. You don't always feel the benefits of DDR5 in normal day-to-day use. Its massive bandwidth really starts to shine when you're doing super specific data-heavy stuff. So if you're a professional who's transcoding video files all day, yeah, DDR5 could literally save you hours. But for everyone else, that extra cash is probably better spent on, say, a bigger hard drive.
And that brings us to what is without a doubt the #1 point of confusion for pretty much everyone. What is the difference between the memory a computer uses and the storage it has? Let's clear this up once and for all.
Right? You see this in ads constantly. A new phone comes out and boasts a whopping 256 gigabytes of memory, but then a powerful laptop only has 16 gigabytes. I mean, based on the numbers, the phone sounds way more powerful, doesn't it? So what's the deal?
Nope, not even close. They are talking about two completely fundamentally different things. And the best, clearest way to understand it is to think of one as your workspace and the other as your long-term filing cabinet. Think about it like this. On the left, you've got RAM. That's your desk. It's fast. Everything's right there within reach. But you only have so much space for the projects you're working on right now. On the right, you have your storage, your hard drive or SSD. That's your giant filing cabinet. It holds everything, all your files, your photos, your programs, permanently, even when the power's off. It's way, way bigger, but it's also slower to go and retrieve things from. So now, the next time you're shopping around, you're armed with the right knowledge. You can ask the right question. Does this machine need more RAM, a bigger workspace, so I can juggle a dozen complex apps at once? Or do I need more storage, a bigger filing cabinet, so I can save my massive library of games and videos? And now, you know the difference.